Good morning, everybody. It is my great honour to introduce the next panel, Combined Heat Compute Challenges and Opportunities Through AI. I'm going to introduce them and then we'll lead into it. So we've got Stefan Frenzel, independent consultant, moderating the panel session. Stefan, Business and Innovation Director at Research Institute of Sweden. David G, I can't pronounce his last name, but he's known here throughout the industry as David G, so I think that's good enough. And then finally, Deborah Andrews, who's a professor at the London South Bank University. So, with no further ado, I shall pass you over in the very good hands of Stefan, and I'm going to sneak out for a cigarette, so I'll see you later.
Thank you, John. It's appreciated. All right, can you hear me? Perfect. So, welcome here to our panel discussion about combined heat compute, challenges and opportunities through AI. So, we have a dedicated session here with experts from the industry. Has been already introduced. So again, I'm an independent consultant. My company is DME, and I have also a history of OCP, leading the OCP EMEA community until recently. And we just have another quick round here. So Isabel, David, and Deborah, also a few words about you, what you're also focusing on.
Can I start?
Yes, please.
Okay, I work at London South Bank University as an academic and a researcher, and I worked with the data centre industry for over 10 years, and I was the founder and the academic lead for the Circularity project, which was developing a circular economy for the data centre industry.
Yeah, and David?
I'm an independent consultant focusing on data center decarbonization and heat reuse. And
okay, sure. Perfect. Isabel, please.
Yes, my name is Isabel Camlin, and I work for RISE, Research Institute of Sweden, which is a research. We have a research facility up in the northern parts of Sweden, of 1,000 square meter, where we do tests within the digital infrastructure. And then my evening job is to be a vice chair of the Swedish Data Center Industry Association.
Perfect. So, to put you guys into the mood, we have a couple of slides to kick off the conversation, and then we go into the panel. So, David, yes, please. This is the tip of the iceberg. This image you're probably aware of from the movie Titanic. Only a small percentage can be seen, and this leading to the next slide, where you can see the majority is under the water. So, and this is also when it comes to the scope 3, 1, 2, and 3, the 10% you can really see, and this is also done, this is solved. And the majority under the water is the scope 3. This is a big challenge of this decade, and this is also what we try to tackle when it comes to combined heat compute. So this is like the way forward. And here, this is how we try to tackle this, really making use of circular economy gear. We recycle the IT equipment and also making use of the heat rejection. Yeah, and this is like the pathway you can see really from the server design, going really all the way from the direct design to the facility. You can see here like a modular data center until a complete ecosystem. With making use of the heat rejection, yeah. And talking about circular economy, here on this slide you can see really the air-cooled server. You can see 3 of them here on the side, and the other side you can see the liquid-cooled server. Yeah, here a direct chip cooling, a cold plate cooling, and the challenge we are really having here, or also an opportunity, is coming also through AI to increase the density. You can see in comparison to an air-cooled model, you can really minimize the height unit from 2U to 1U. And then you can increase also the number of the racks, of the servers in a rack, yeah, because you can take off the heatsink, reduce the height unit, and then you have a direct chip cooling here. In this model you can see on the side. So this is a way forward, really harvesting from liquid cooling, here in this example from cold plate cooling, and also making use of already of second life servers to extend the lifetime of the service. This is a video. Yeah, please, all material will be available after the fair. But in this video, we will not show here. Here you can really evaluate the ratio of the embedded carbon in a building and the IT equipment. And the ratio is, as you can see in this video, is 1% of the embedded carbon is in the building and 99% is in the IT equipment. Yeah. David, all yours.
Yeah, thank you. So, showing the way to industry, we show how to make densifying of the racks, how to handle new challenges of AI servers, which is 1000 watt GPUs, how to design the rack, how to achieve the high temperatures, which are increase the efficiency of the system overall, how to implement that in the same form factor as air-cooled design, where we have 12 racks and 90 kilowatt, and how to shift to 1 megawatt 16 racks. So we show how to implement that through open source solutions. And if we talk about the decarbonization, here you see that there is two processes going in parallel. Data centers, which convert the renewable energy to the thermal heat dissipation to the ambient air or environment, and at the same time we use the gas to heat up the buildings. So when we make circularity and use the heat from the data centers, we reduce heavily the fossil fuel consumption, and we achieve that circular decarbonized economy. And another thing is that we also have open source design of the greenhouses, of the fish farming, that can be a complete ecosystem design. And Kristen Bellady from Microsoft said that make data center disappear. It means that data center should not take the land, they should provide the land. They should not take the energy, they should provide the energy. And they should not take the water, they should provide the water. And the way how to do that is an example of open source underground data center, which can be located under the trade mall and provide the high enough power for heating city center. There is a supply and demand match, and you can fit with 3,000 racks.
Okay, perfect. Thank you, David. Okay, now we can really start into the discussion. I would like to start with ladies first, of course, with Deborah. Deborah, please elaborate here with us. AI is a buzzword. AI is really accelerating the industry. This is also having significant increase of the compute. So the compute needs to change. Also the server design, there needs to be some changes. Also when it comes to the server design, the IT equipment. So what do you think can be done to minimize the environmental impact of that?
Okay, so I think we're all aware not only how rapidly the data center industry is growing, but then the sort of exponential increase in AI, and the predicted increase is just astonishing. So we need masses and masses and masses and masses and masses more servers, etc., to realise the sort of capability that everybody is talking about. And I'm a little bit concerned because I think there's a danger that we might make the same mistakes or repeat the same mistakes that have already been made, where servers are not designed for either easy disassembly to facilitate reuse, upgrade, and easy recycling. So I think we have to, particularly looking at open source rather than just models that are discrete to particular manufacturers. I think we really have to think about not just designing servers for immediate use, but for use in 10, 20, 30 years. Can chassis be, because they're one of the elements that is not going to break, in inverted commas, can they be designed, and can designers consider reuse, replacing the guts of the equipment repeatedly, etc. So there's a lot of potential to shift to modular design and to ensure longevity. And that's really the only way, because the energy demand and resource demand is going to be so high.
Yes.
It's the only way that we're going to even begin to maintain some kind of equilibrium in terms of resource use.
Absolutely. And Isabel, this goes in a similar direction. The next question here. So basically, yeah, AI requires more compute, and you are questioning, are we not reaching the physicality limits there?
Yes, definitely. So what we can see now is that we need to look at what are we doing here? Yes, we are trying to process a lot of things on a small microprocessor, and that one today is the heat flux from it is like a rocket motor. 2030, the number of transistors that Intel want to put on it, it's going to be a heat flux that is like a nuclear station.
Yeah.
And we're talking about a little chip. So no, there is the physical limitations for cooling it with air will, we are reaching that limit right now.
Okay.
So yes, definitely, there need to be other ways of cooling it, and we know that there are a few technologies that are coming just around the corner.
Absolutely.
Yes.
Next question. This goes to David. So we've seen on the slide the buzzword everyone is talking about is combined heat compute. Can you really elaborate here? Who were first when it comes to combined heat compute? And what was the reason for that?
Yes, so the heat reuse is already done for many years in that industry. And first project where I was involved was in Finland, in Mäntsälä, where is hyperscaler invest with local heat pump producer money in the project to heat up the Mäntsälä city. And it was in 2014, so already this project worked for 10 years. And reason to do that was the business, because you invest in the heat pumps, you invest in the heat rejection system in the data center, but in front of that you get paid for the heat which you provide to the city, and you avoid of the using of fossil fuel. So you already achieve this net zero targets in city scale. So this is the challenge for the today's city authorities. And the next project was repeated in Odense with Facebook, where they also adopted these fresh air cool designs of hyperscalers to provide the heat for the local heat company, which install their heat pumps and transfer that for the city. And in this project, different approach from the point of view of the financing, because in first case, the data centers get paid for the heat which they provide. In second case, they just provide that heat for free. But anyway, in both cases, these examples can be financially motivated. And today, it's also motivated by the point of view of the carbonization.
Yeah. Deborah, so you already said, and AI is increasing the compute, but also what you mentioned already is also increasing the energy supply. Can you also share with the audience the implications, what we've seen on the slides, moving from a linear to a circular model using heat reuse? What are the implications on the decarbonizing the industry? Yeah.
So it's the perfect circle, really, reusing all resources, not just physical resources, but heat, and stop calling it waste heat. Change thinking. It's an untapped resource. The problem is, are we going to be able to put data centers where the heat is going to be needed?
Exactly.
Or do we build remote data centers and then, it's transferred to urban environments? What are the losses, etc.? So there are a lot of challenges around this, and also looking at disruption. If we are going to try and reuse heat from more urban data centres, enterprise centres, etc., that are already in cities, what are the implications for disrupting the current infrastructure, utilities infrastructure? So I don't think there are any perfect answers to that, but I think we've got to be careful about not rushing into this,
Yeah.
you know, thinking about planning issues and so forth, and you know, citing places to maximise the benefit of heat.
Isabel, you want to add straight away something?
Yes. So,
Sorry.
no, I think exactly on the same topic. Before COVID, I was also sitting on stage, and I was given the analogy that where do we place our data centers? And then I said, you know, the Vikings. So where do the Vikings establish? Well, they establish where there is good communication, where the rivers meet with the sea. There they put down their houses. But this is the exact same thing that is happening right now, where the power cables meet with the internet cables. The big hyperscales, you can look at the map and you can see it. But now, actually also coming a little bit touching, we will touch upon that a little bit later, but with the new regulations coming from EU, there will be a third dimension, and the third dimension is the reuse of heat.
Yeah, agree. Yeah, we really need to relocate data centers. I think everyone is agreeing. Where the demand is also for the heat rejection. Yeah, in the middle of nowhere on the green field doesn't really make sense, right? All right. So, David. So, combined heat compute. We know where everything has started. What is the reasoning for? What is the fact, apart from AI now, what are the crucial changes in the last year we have been facing, which is also increasing, which happened, and how we can overcome this now? When I'm talking about the energy crisis, for example, with the high prices due to the war in the Ukraine, where we have really high prices of the fossil fuel fluctuating also. So what are the solutions to overcome this?
I try to explain why right now is attention for the heat reuse. So first thing, as you said, is energy crisis. So the price of the heating for people is increased. There is a lack of energy resources in Europe, and that's all stimulate to have a look from another angle for heat reuse for data center. The second thing which has happened last year is a new legislation in Germany that data centers have obligation to make 10% heat reuse. And now legal departments of data centers push on the engineering staff to make that. And the third thing which has happened is that new generation of the servers which have high heat rejection and stimulate to shift for liquid cooling. And this is also goes hand in hand with heat reuse.
Yeah. And Deborah, so talking about changes, so what are in your view the changes which needs to be done to really in the data center industry and in its services to minimize really the decarbonization? What needs to be done, put it this way, short and then on the long term? Yeah.
Okay, so at the moment everybody thinks, oh, service rounds of action, we just send them to a recycling plant, that's great, we'll buy some new stuff, job done. Okay. Unfortunately, the recycling infrastructure it just doesn't exist in anything like the scale that we need to exist to manage all the electrical and electronic waste that's coming on stream now. So if we have big changes in the industry and upgrades, we need to have different kinds of servers. The old ones are probably going to come back into the waste stream, etc. And we don't have an infrastructure to deal with them. So we have to change, again, ways of thinking rather than just buying new to extend product life. And it sort of goes back a little bit to design challenge,
Yeah.
designing things that can be upgraded efficiently and effectively. But also I think it's really important for the data center industry, who, I mean, it is one of the most resource intensive sectors, to push and encourage development of a proper recycling infrastructure, because many of the materials that are absolutely essential for use in servers and so forth are critical raw materials. We've seen disruption to some supply chains, and unless we start to reclaim those and be able to reuse them, there's actually a threat to the operation of the data center industry. So I'd say, you know, as a body, we need to really push for other services like recycling infrastructure and reuse infrastructure to be developed.
Absolutely. And as we all know, also legislation in Europe is changing. And with Isabel, we had already a bit of a controversial discussion. What really happened, you know, with the European directive, energy directive from the European Union, which also some countries are picking up. This time, the Germans are leading this process. They're not behind, they're leading. More countries are jumping on this. So coming from the AI perspective, can you also give some input from your side, from your view, if this is really the right way to go forward, to have a framework in terms of also changing the legislation in Europe?
Yeah, so my view is it is really important to set the framework right now, because this with AI will otherwise get out of hand. And worst case, it's going to be like a Bitcoin world that no one wants to touch. But that's not what we want with AI. We want it to be actually a sustainable AI process here. And I think we have the chance now with the regulations that are coming. So the Energy Efficiency Directive has been developed in close collaboration with the industry, which I think is really, really good. But we really need, this is a directive, and an EU directive is kind of a overall a recommendation for all the countries when they actually put this into a law. And here I urge all of you that are in this sector to engage, because when it becomes a local law within your country, that's what you really need to follow. And what we have seen is a little bit, I would say, different knowledge levels within our governments on what they are really actually deciding upon. So while EU was working closely with the industry, we didn't get everything we wanted, but kind of in the direction of it. Now when it becomes law, it can be, you know, just taking a copy paste of something. And what we have seen in Germany is that they have already now set levels, for example, with PUE. They have set levels of how much you need to reuse, percentage of what you need to reuse your heat. Reuse of heat is one thing, but when it comes to, for example, the PUE, we need to question ourselves, is that the KPI that is going to be steering? It might even be contradictory when you want to reuse the heat. So it's really important that we all work together closely with our local governments when these laws now are to be written. And Germany want to go ahead, and they have a kind of formed a way of punishing if you're not doing it.
Those Germans.
Yes, so you actually have a fine if you don't do it. The thought of the EU Commission was to actually start to measure things, so and also show to investors that you are sustainable. And then actually what we see from an investor perspective is that they are asking more and more for sustainable data centers. So they are more putting the carrot out there instead of the stick. So we really need to think about, are the Germans right this time?
So, but yeah, I fully agree. In the end of the day, the market or the business case will regulate it themselves. Of course, if we have a certain framework in terms of legislation, it needs to be done right. I think this is also helping, yeah. But in the end of the day, the higher prices on fossil fuel, this is already changing, and we're realizing now. We're talking to people in the industry, they are approaching us because we've been preaching this since a couple of years. All right, David. Hopefully we're not running out of time, but the last question I have for you, again on combined heat compute. The challenges we already mentioned here, but also this would go for all of you in the round. What would you like to take the audience home? What will be the game changers now in the industry? They really need to have a look at it for the next coming years. What we just discussed here, how to decarbonize the industry, which kind of technologies are really important. What's really like a brief round to everyone.
I want to say about the challenges and how overcome it, right? So today, if we talk about the heat reuse, the main challenge is to match demand and supply, because when we need a high demand of the heat in the city center, we can put there only small server rooms, which is not enough. And where we have a big data center, hyperscaler, it is out of the city center. And in neighbor we have just small villages, and 300 megawatts can be utilized only 1 megawatt. So there is a mismatch. And one of the way how to do that is underground data centers, which I show in the slide. And at the same time, another thing is the application. So if we talk about the heat reuse in the cities, it is limited by the cold season. But we need to find the like industrial process which will fit for the data center heat rejection. Round year, 24 hours, 7 days per week. And that example we found in Middle East for water desalination. So it's a system thinking. So in Dubai, they make 1 million cubic meter of the desalinated water each day. And this is connected with a lot of pumps energy consumption for reverse osmosis. At the same time, we have data centers there which use a lot of energy to cool down the IT equipment. And 10 megawatt goes there, 10 megawatt goes there. When we combine that in one system and we use the heat rejection from data center for water distillation process, so thermal desalination, then we use 10 megawatt for data center operation, and this 10 megawatts goes to the water distillation. In this case, instead of using 20 megawatts, we use only 10. And by this, we decrease the impact on energy grid.
Okay.
So my message is to make system thinking from the scale of the city operation, data center operation, and integrate them together.
Okay, David, I know you're passionate about this. This was not a brief answer, but anyhow, the same question to Deborah and Isabel. What will be the game changers to really decisively accelerate the decarbonization in the industry?
Okay, there's no short-term solution. We need to, think longer term. David, you've stolen my thunder here a bit, because I was going to say whole systems thinking. Again, I think one of the challenges, the speed and scale of the development of this industry means that there are lots of subsectors, lots of brilliant people working in subsectors, but they don't talk to each other and understand what everyone else is doing. And we really need to have a whole systems approach to this problem, and to consider and understand how the actions in every subsector affect or have an impact on every other subsector. It's a big challenge, but until we do that, I think we're going to be, repeating this or making the same kind of mistakes.
Absolutely. Isabel, last but not least.
Well, now they said system, and then you talk about one kind of system, and you said also system, but even a bigger perspective. But I think we can look at our own, within our industry about the systems. So a very, how to say, an easy example to that is that we will see solutions of, we talk about hybrid IT. There will be, for example, hybrid cooling. And we also need to look at, for example, if you look at the holistic cooling, you can actually not just have a cooling machine that has a set point in the room. What you want to cool is the actual chip on the server. But if you combine the control systems, you look at the sweet spot of the server, you know, everyone in this room knows that it's really warm out there, up here, but it's not so warm down here, because heat is going upwards. So you can actually steer that as well. But then we need our own industry to have a bigger system thinking. We need the IT guys and women to talk to the facility ones. So there is another kind of system thinking, but there is a lot of gains, and we have shown that in our research where we have done tests about this at RISE. So yeah, a lot of exciting things going on.
Absolutely. Absolutely. Exciting times, really like a big momentum in the industry where everyone can see how we do in time-wise. Is there some time for questions? All right. Guys, are you straightforward? Have some questions here to our panelists? I can hear. Do we have a mic also?
No.
There. No?
No, he's going to be disruptive.
No. I can get. This gentleman has asked. Will have a question there. Please go ahead.
Hi everybody.
Hi.
Deborah, you touched on the servers and recycling. How much are we able to extend the time before we replace the servers?
That depends very much on how they're designed. And you know, at the moment, we find that there are components that are designed for individual servers. You can't swap components between generations or even models, you know, they're produced by the same manufacturer. So it really depends on the server and also the way in which the data center is set up and operated as well. But I mean, Google, they recently claimed that they are extending life, and we argue from the research that we've done, not just looking at hardware, but looking at performance, compute performance and energy consumption and so forth. It should be possible to extend server life to about 10 years, but it really does depend on the requirements of the customer. So maybe customer A has very high spec, needs the servers can be either tweaked or whatever, sold on to a second customer whose specifications and requirements aren't quite as high. So we should see a kind of cascade of equipment, you know, sort of downwards, if you like, but that sounds, downward sounds negative, but it,
Going hand in hand with software.
That's a huge challenge, the software issues,
All right. Thank you very much. I can see over there has been a hand raised. Another question here from the audience.
Hello. I'd like you to comment a bit on the development of edge data centers and how that affects the scaling of, in particular, heat reuse. It seems likely in the run up to 2030 there are going to be more edge data centers. There are smaller scale than, for example, hyperscale data centers. How do we build heat reuse into the edge?
Very good question. I think, David, I think this is a big one for you, because when it comes to all the data center sites.
To show the example.
Yes.
Yes. So this is open source modular data centers, and you see it's a container-based AI model, which is with 16 racks, and it can have up to 1.8 megawatt heat rejection, and that can be fitted in the urban areas and supply the heat, and it will be exactly like the edge solution. And it is open source. It means that anyone can take that and use, improve, and give back.
Okay.
I'm going to throw another answer in here. So, in the first panel session, we had Neil Kalita talking about a greater need to be looking at energy master plans for data centers and utilities. And I think this is very much connected with that. So we really do need a spatial strategy. I don't think we can leave it to the open market to decide where it's going to locate its edge data centers. They need to be located in, for instance, housing estates, where they can provide CDN services to the local community, but also their heat as well. So this is very much stuff that we did with the Catalyst project, which was Green IT Amsterdam about 3 years ago. And definitely a more spatial strategy is required. So it's a bit more of a master planning. So we need to discuss with the local authorities exactly where they're planning to put their new housing estates, and this is where the edge needs to be. But on another token, for instance, if you put an edge on a crossroads in a cold country, then you can use the waste heat to heat the roads. Because most car accidents happen in snowy weather at junctions. So if you can use the waste heat to just heat the road up so that you've not got snow and ice, then that's one way of doing it. Urban farms, big green doing swimming pool stuff. So I mean, the potential is huge. Really is.
I just want to add that edge data centers allow you to put them where there is no district heating. So you can make short connection to the neighbor buildings and avoid the issue when you have urban areas where there is no developed district heatings.
All right.
Any other questions? Yes, one over there.
So high level, I think the heat we use is, I agree with you with it, and it sounds great. But what cooling technology is actually going to enable this? Should we look at direct chip cooling or other technologies like immersion should be considered as well?
I can just add that, for example, this design with 3000 racks, it's flexible. It can use air-cooled racks, it can use on-chip cooled racks, and it can use immersion racks. So the answer is to have flexible infrastructure. So you are not affected by the kind of the cooling system. You can use all three of them in a one data center. The flow rate is the same, the difference in temperature delta T.
Yeah. And what we also learned basically, can you hear me?
Yeah.
Is if you go back to the rack design, there's also no cooling method dominating over the other. So what I'm saying is, if there is a need to change from air cooled to liquid cooled, the percentage of the rack will always be air cooled. Yeah. So let's say what we said, if you change to liquid cooling, have a direct chip cooling, for example, or an immersion cooling, the percentage around 20% or even a bit more is still air cooled. Yeah. Because there is still storage, memory, and so on, which still needs to be air cooled. Yeah. So it will always be a hybrid solution. And immersion cooling, everyone is talking about, will also accelerating. The business is coming from a niche in Europe, and it will scale, but it will not be the one and only solution. That's what I was trying to say.
Yes, I also agree that there is software. Software defines the hardware. Hardware defines the cooling method, and cooling method defines the infrastructure system, not opposite. So you can put immersion cooling, and after that all the equipment put in the immersion. So first of all, you should look on the software. And this is what said Isabel, that we should look comprehensive, even internal data center design. We should look from software to facility and make design in the best way.
And this has also changed the industry upside down. First, in the past, it was a building, and then it went into the hardware, the application, and then the cooling method. This has been changed, which makes totally sense, of course. All right, further questions here from the audience? There's one over there. Yes, please pass the mic. Please go ahead.
I'm Frenzel from Perstorp Chemical Sweden. Just about what you actually mentioned, I'd like to understand. What do you think about the choice of the fluid? Because when it goes to the cooling of electronics, we have an experience of fluorinated fluid for many years, and we know what it means. Now we are actually thinking of like immersion cooling and different types of chemistries used in the cooling methods. So when it goes to the liquid cooling, I think what to avoid, not to start the same thing as we did in the past with the fluorinated fluid, to have a fluid that has the right environmental profile and right chemistry that will not, put us in trouble again in terms of biodegradability, performance, recyclability, and such. So I would like to know your opinion about that.
That's a fair question. I'm not an expert into fluids and the dielectric liquid, but maybe Isabel can elaborate.
I'm not an expert in fluids, but I'm working with experts in fluids. There is not a single answer at the moment. There is a lot of research taking place, and I think this is really, really important. It needs to be done. The research needs to be done. The calculations needs to be done, and the real tests needs to be done to verify and further explore this. But there is definitely a race right now going on. But I don't believe we will see one single solution for it.
I believe there's a panel session with the erstwhile Dr. Jonathan Summers talking about immersed compute elsewhere in the show. So maybe pop into that one and we'll tell you about it.
Valid point. So, further questions from the audience? I think time-wise we are still okay. No. Wrong information. So, we are still around. We are still here for the full 2 days. You can find us in the speakers lounge, for example. We are happy to answer questions. I also asked afterwards, if you have some questions, please feel free to come to us. We're happy to answer. Hope you enjoyed the show. You take care and all the best. Thank you, guys.